This is for Algebra 1. This lesson is actually for direct variation, but we started the class out remembering what we know about slope. If you have a graph, slope is rise over run. If you have a line on it, you find two good points, any good points. You make a right triangle, you count your rise, 3, and you count your run. And remember that this is your rise and this is what goes on top. So my slope here would be 3 over 5. The thing you got to remember to do is look and see, is your line going up and it's a positive slope, or is it going down and you need to put a negative with the slope? If you have an equation, y equal to x minus 1, the slope is the number in front of x. We learned yesterday that the letter for slope is m. So for this one, m is equal to 2. If they give you 2 points, you're going to subtract the y's on top and the x's on bottom, so you're going to have a fraction. Remember, it's x, y, and it's x, y for your point. So you would say 3 minus a negative 5 on top, and you would say 1 minus 2 on bottom. Use your calculator because of the double signs and all that. You're going to have 8 over negative 1. We don't like a negative in the bottom, so negative 8 is my slope. We took a short quiz on slope, and then we moved forward with direct variation. Direct variation is described by an equation in the form of y equal kx. K is not going to be 0. You've got to have it there. So if you have y equal kx, we say that y varies directly as x. In other words, y is going to do the same thing that x does. If x gets bigger, y gets bigger. If x gets smaller, y gets smaller. This k here is the constant of variation. That's how much it's changing every time. It's going to get 3 bigger every single time if it's y equal 3x. Example 1 says that for y equal 1/2 x, the constant of variation is 1/2. That's telling you that you just look at the number in front of x. If we had y equal 5x, your constant of variation would simply be 5. If they give you some information, y varies directly as x, y is 30 when x is 5, and they want you to write a direct variation equation, you start with your formula, y equal kx. They gave you a value for y and for x, so you plug those in. 30 is equal to k times 5. You solve that to figure out what k is. We're going to divide both sides by 5. 6 is equal to k. You take that and plug it back in to the formula. So y is equal to 6x is your equation. Okay, that's for part A. Part B wants you to use that equation that you just found so that you can figure out what x is if y is 18. That means that you're going to take 18 and plug it into this new equation where you see y. So 18 is equal to 6x. We're going to solve by dividing by 6. 3 is equal to x. 2 parts, 2 answers. So same thing. We're going to start with y equal kx. Y is 4 equals k times x is 2. Divide by 2 so we know what k is. 2 is equal to k. So your actual equation is y is equal to 2x. It's part of your answer. We use that equation to figure out what it would be if x were 16. Y is equal to 2 times 16. So y equals 32. That's your solution. If y is 9 when x is negative 3, same thing. 9 equals k times negative 3. Divide both sides by negative 3. Negative 3 equals k. So my new equation is going to be y is equal to negative 3x. Now you're going to take the y equals 6 and plug into the new equation. 6 equals negative 3x. Divide both sides by negative 3. And negative 2 equals x. Second part of your answer. So here is a real-world example of how we use direct variation. This is dealing with retail. If you're in the retail business, you're selling something. It could be clothes, could be candles, whatever. But retail means you're selling. The total cost, C, of bulk jelly beans is 4.49 times the number of pounds. Write a direct variation equation. They have actually given you the constant of variation, that 449. So your equation, total cost is, so C equals 4.49 times the number of pounds, so times P. There's your direct variation equation. Then they want you to find the cost of 3/4 of a pound. You just put that number in for P. C is equal to 4.49 times 3 divided by 4. C is equal to, I think it was 3.36. You also see real-world applications in chemistry. Charles' law states that at a constant pressure, the volume of a gas V varies directly as its temperature T. A volume of 4 cubic feet of a certain gas has a temperature of 200 degrees, absolute temperature. Write a direct variation equation that relates to variables. The order that it shows up in the problem is what you're going to write. So they give me V. It varies directly, so there's your equals. As its temperature, we've got to have a K. The other variable was T. So there's your equation. Then they want you to find the volume of the gas at 250 degrees, so that goes in for T. Before we do that, we need to use the information they gave us. V is 4 equals K times 200. Divide. So you get 0.02 is equal to K. So your actual equation is going to be V is equal to 0.02 times T. It's not a very good T. Let me redo that. Times T. There's your equation, which is the answer to part 1. Then they want to know the answer for the same gas at 250. So you just plug that back into that new equation. V is equal to 0.02 times 250. And so your volume is equal to 5. This takes you to the assignment for direct variation. Remember that the formula for direct variation is y is equal to kx. K is the constant of variation. Come see me during speed if you have questions.